Delaware Tech, Chem 100, Chem 110, Unit 2 continued, classification of matter. We've already talked about classification of matter in terms of substances versus mixtures of substances and whether they're homogeneous or heterogeneous, but let's talk about those individual substances. And one way to classify them is by determining whether they are elements or compounds. And it's actually fairly simple to distinguish between these two. Elements are defined as the simplest kind of normal matter, and that's really not the greatest of definitions. Really, the better definition would be they are composed of only one type of atom. In other words, if you see a formula for something and it can be made with only one symbol from the periodic table, and I know we haven't talked about the periodic table yet, but there are 118 different symbols on the periodic table because there are 118 known elements. If it is composed of only one of those elements, whether it is one atom, two atoms, 4, 8, etc., it is an element. It is the elemental form of that element. And it can be composed of single atoms. We have single atom elements. But we also, these cannot be broken down into any simpler substance, unless you're talking about nuclear reactions. And if you're taking Chem 100, we will not be covering nuclear reactions. So examples of single atom elements are carbon, lithium, iron, uranium. So carbon is one of the few non-metals that is a single atom element, but it can also be found in multiple atom forms as well, molecular forms as we call them. All the metals are considered to be formed of atoms, so lithium, iron, uranium, etc. And in addition, there are a collection of gases on the right side of your periodic table, the last column of the periodic table. Those are known as the noble gases, not Nobel, noble gases. They include helium, neon, argon, which we've already talked about a little bit, xenon, radon, etc. And these are gases that are so stable that they only need one element, one atom in their natural form. They don't tend to form compounds. In fact, forming compounds with these gases is extremely difficult. The first time it was achieved was not until 1962, as a matter of fact. So these are the single atom forms of elements, but we also have elements that are composed of 2 or more atoms. We have the 8 elements that are typically found as what we call diatomic molecules. That is, they are formed of 2 atoms, di meaning 2, atomic meaning atoms. So hydrogen, H2, nitrogen, N2, oxygen, O2. These are all gases. Fluorine gas, F2, chlorine gas, Cl2. Bromine is actually a liquid. Bromine, Br2, is a liquid. I2, iodine, the natural form of iodine, is actually a solid. It's a dark grayish, purplish crystal. You may have seen these. They used to even sell these in the drugstores. And astatine, another element in that same column. If you look, it's the second to last column of elements: fluorine, chlorine, bromine, iodine, astatine. Those are called the halogens, and they are also found in diatomic form. And that is, their elemental form has 2 atoms. They are still elements, and they are molecules, but they are elements because they are composed of only one kind of atom. And sulfur, S is the symbol for sulfur. Sulfur is frequently found in S8 form. In other words, 8 atoms of sulfur form a little 8-sided ring, and that is the elemental form of sulfur. There are actually other elemental forms of sulfur, but this is one of the more common ones. And then phosphorus has a number of elemental forms, at least 4 different fairly common forms, and one of them is a form that has 4 atoms forming a tetrahedron. This would be P4, and this is one of the common forms of phosphorus. So you can see that each one of these individual formulas is composed of only one type of element, and even though these are molecules because they contain more than one atom, they are all elements. Now, compounds are called compounds because they are compounded between 2 or more elements. So you have to see at least 2 symbols in the formula for them to be a compound. And these substances can only be broken down by chemical means. In other words, you can't separate hydrogen from oxygen in H2O, water, unless you chemically break down the water itself. So when broken down, the pieces have completely different properties. If I break down H2O into hydrogen, which is H2 gas, and oxygen, which is O2 gas, those two gases are completely different in behavior and properties than the original water they started with. They are made of molecules. If they are another type of compound called ionic compounds, we officially call those formula units. We'll talk about that in Unit 4, but we'll refer to all of the substances that are compounds, the simplest version of a compound, as a molecule, and they have to have at least two kinds of atoms. H2O has H's and O's, hydrogen and oxygen. CO2, carbon dioxide, has carbon and oxygen. So they have to have at least two. They can have many more than two, but they have to have at least two different kinds of atoms. We're not talking about total atoms, we're talking about kinds of atoms. So examples are water, H2O. C6H12O6 is actually the formula for many things, including a lot of different types of sugars, and the most famous one would be glucose, but it's also the formula for mannose and galactose and literally dozens of other sugars. The next one is iron 3 chloride. I know you don't know how to name these yet, but iron 3 chloride is an ionic compound. We'll call it a molecule for now, but it has 1 iron and 3 chlorines in it. The next one, H2SO4, is a very famous molecule in chemistry. This is sulfuric acid. B2H6 is a compound called diborane, and it won the gentleman who worked with it, a man named Herbert Brown, and won him a Nobel Prize. And then you can have proteins that have many, many carbons and many, many hydrogens and many nitrogens and many oxygens and a reasonable, sometimes zero, but sometimes more numbers of sulfurs. So you can have very large molecules with literally thousands or even hundreds of thousands of atoms. We even have molecules that have literally millions of atoms in them. So they can get quite large, but this is one formula. This is one substance that happens to be a compound made with carbon, hydrogen, nitrogen, oxygen, and sulfur. So please do not confuse this when you see something like this. This is a single compound. It's a single substance, one substance. It's not a mixture. These are all attached to one another. It is a single substance. It happens to be a compound, and it has many, many atoms in it. So let's talk about distinguishing between a couple different types of forms of matter. Compound and mixture. Now, compound and mixture are not exactly parallel. We'll talk about the actual division and classification in the next slide. But I'm making this comparison to show you how the elements that comprise a compound or the elements that comprise a mixture can be separated in very different ways. And I've already mentioned this a couple times, but I'm going to hammer this a little harder here. So a compound is a single piece of a substance. It's a single substance. It's a substance that happens to be made from more than one kind of atom linked together, and we call those molecules. If you have at least two atoms, it's called a molecule. And in this case, these are molecules with at least two kinds of atoms in it to be a compound. Compound refers to the fact you're compounding two kinds of atoms, whereas a mixture is two completely different substances. You could have a compound and a compound. You could have an element and an element. You can have a molecule and a molecule, an atom and a molecule. So there are a lot of different things. As long as you have two separate formulas, that's a mixture. Now, one thing that distinguishes these two is that if you want to separate the atoms, the elements that are part of a compound, remember these are chemically linked to one another, you have to break those chemical bonds using chemical methods or chemical changes. Whereas a mixture these are separate substances, so you can just physically separate them. And physically separating them could be something as simple as using tweezers to pull crystals apart from one another, or boiling water off from a mixture of water and salt, or water and sugar, or evaporating some gasoline from oil at a certain temperature. Those are physical means, and we'll talk more about those in the very next module. So a compound is only a single substance. It's one type of substance, H2O, FeCl3. Those are individual compounds. They're individual substances. Whereas a mixture is as the name suggests, a mix of at least two kinds of substances. And they could be compounds, they could be elements. So carbon steel. Carbon steel is made from two kinds of atoms. Iron atoms with a little bit of carbon in them. And you can vary the composition of this. So carbon steel could be 1.1% carbon in the steel, or it could be 0.7% carbon in the steel. In other words, in the second steel, it's 99.3% iron and only 0.7% carbon. But if you look at the compound, H2O, it's always the same thing. There are always two atoms of hydrogen for one atom of oxygen. The ratio of those two is set in stone for that particular compound, for that formula. The formula tells you the ratio. In iron 3 chloride, there is exactly one iron atom for every 3 chlorine atoms. It's a 1:3 ratio. There's no playing around with the ratios, or you would have a completely different compound. So now we'll talk about the real questions to classify matter. And there are 4 questions I've come up with here. And this is the order you should ask these questions whenever you're asked to distinguish between different types of matter. And let's go through the questions one at a time. So the first question is, how many substances? Now you know how to recognize a substance. It has a single formula. If it's one substance, well, we call that a substance. If it's more than one substance, we call that a mixture. And we've already talked about this. Is it the same everywhere? In other words, is it extremely well mixed? Well, if it is, it's homogeneous. If it's not, it's heterogeneous. So remember, air, very well mixed. Sugar water, salt water, once you've mixed it up, very well mixed. These are homogeneous. Gravel, chocolate chip cookie, cereal sitting in milk. Those are heterogeneous mixtures. Rusty nail, gold-plated bracelet. Those are heterogeneous mixtures. Now, the next question you should ask is, you look at each substance. So if you have one substance, you're just going to ask this question once. But if you have a mixture of substance, you have to ask this question and the last question for every single substance in your mixture. So look at the first substance and ask yourself, how many different elements are in that substance? If it's composed of only one kind of atom, it's an element. If it's composed of more than one kind of atom, it's a compound. Then you ask the question for each substance again, how many atoms in each? So this is a different question. It overlaps, but it is not the same question, so be careful. How many atoms in it? So we're talking about total atoms. We don't care if they're the same or if they're different. How many total atoms? If there's a single atom, well, it's an atom, and atom is the smallest component of an element. We have some elements that are naturally formed as molecules, but if you can still break them down into atoms, like O2 is a molecule form of oxygen gas, but we can break oxygen O2 down into individual O atoms, so that's still that element. So if it has one atom total, it's an atom. If it has more than one atom, 2, 3, 7, a billion atoms, that's a molecule. And so you will notice something here. An element can be either an atom or a molecule. But a compound, since it's made of at least 2 different kinds of elements, you have no choice. It can never be an atom. It will always be a molecule, or as we'll learn later, things that are like molecules called formula units. But for now, we'll just call them molecules. So here's a little visual quiz, and I have 8 examples here. And what I'm going to tell you is each colored ball, if it's a different size and a different color, that's a different kind of atom. And you notice in this particular drawing, there are only one kind of atom in here. They're all blue balls. And I know this is funny to everybody, but they are blue balls. And they're all separated. You can see they're all you can envision them moving around inside this container. They're all blue balls. They're one type of atom, and therefore that's one substance. And since it's one substance, well, it's well mixed, so it's automatically homogeneous. And the next question to ask, the third question to ask is it an element or a compound? Well, it's only composed of one kind of atom, so it's an element. And then the last question is, are they atoms or are they molecules? Well, each one is composed of a single atom, and therefore they must be atoms as opposed to molecules. So they're element form and atom form, and here's the answer. So let's look at another example. So you see here now it's all double red balls. They're all double red balls. In other words, each piece of substance here, each individual component is composed of two red balls. They're linked together. So it's all one substance, so you know that. And since it's only one substance, it's automatically homogeneous. So the third question is, let's look at one of these and ask the question, is it an element or is it a compound? Is it composed of one kind of atom or is it composed of more than one kind of atom? And I think you can see it's composed of one kind of atom, and therefore it is an element. And then the last question, is it composed of atoms, that would be single balls, or molecules, more than one ball linked together? Well, it's clearly molecules, so our answer is that it's a homogeneous substance. It is an element form, or the elemental form, and it is a molecular form, or it's in molecules. Now look at this one. You can see clearly there are at least two different things here. In fact, there are exactly two things here, two kinds of things here, two kinds of substances here. So you automatically know it's a mixture. So your next question is it well mixed? Well, a lot of you may say, well, no, it's not perfectly well mixed. But remember, there has to be a certain amount of randomness in any drawing, and this is as random as someone can draw in PowerPoint. So we're going to consider anything like this randomly mixed, evenly mixed, homogeneous. So you will know when you see a heterogeneous substance as homogeneous mixture, because it will be very obvious that they are not well mixed. So here it is a well-mixed mixture, therefore it's a heterogeneous mixture, and we have to look at each of the substances, each of its components individually for question 3 and 4. So let's look at the yellow balls first. Clearly the yellow balls are a single element. They're only made of little yellow balls. And they are made of single atoms. They're each one ball, one atom, and therefore that is an element form that it happens to be an atom form, an atomic form. Now, if we look at the red substance, well, the red substance are pairs of atoms linked together, so okay, we now know that it is still an element because it's only one kind of atom, medium-sized red balls, and it is a molecule because there are two red balls. So remember, don't confuse the distinction between element and compound, that's looking at how many types of atoms there are, versus looking at atoms versus molecules, that is concerned with how many total atoms are involved. So in this case, we have the situation where it is a homogeneous mixture, it's well mixed. We have two substances, the yellow one is an element, and the red one is an element. And then if we look at the atomic structure of these, the yellow one is simply an atom, and the red one is a diatomic molecule. And we'll talk about diatomics later, but it's a molecule. It's composed of at least two atoms. Look at this one here and make sure that everything looks the same. And you can see that each of these units of substance here are a large blue ball with two little yellow balls attached to them. Every one is a large blue ball with two little yellows, and convince yourself by looking at everything. They may not be all attached exactly the same way, but that's just my drawing in PowerPoint. So it's one substance, so it's automatically homogeneous. We don't have to worry about that. And then there's only one thing to look at to ask questions 3 and 4. So the first question is, does it have more than one type of element? Well, clearly it has two kinds of elements, large blue balls and little yellow balls. So we know it's a compound. And if it's a compound, it has to be a molecule because you have to have at least two atoms to have two different kinds of atoms, two or more kinds of atoms. And this one has three. So we know this is a substance. It's by definition homogeneous because there's only one. It's a compound that is composed of molecules, like all compounds would be. Here's another obvious mixture. We have the blue-green molecule, and we have the yellow atom. So we know it's a mixture. It's fairly well mixed by the standards of drawing in PowerPoint. So it's homogeneous. We have two things. The yellow is an atom. The yellow is an element and an atom. And the red-green is clearly a compound that is composed of molecules. So we would write it as mixture, homogeneous. It contains both an element, the yellow, and a compound, the red-green, and it contains single atoms, the yellow, and molecules, the red-green. So this is how you would write the answers if you were taking a test in order to distinguish each of the four questions. Here's another one. Take a look. I'll give you a second to try to figure out what this is. I think first of all you can see it's a mixture. They're not all the same. We have red-green molecules and we have blue-red molecules. And it's clearly a mixture. We're going to call it as mixed as possible in PowerPoint, so it's homogeneous. And let's look at them individually. Well, the green-red molecule is clearly a molecule. It's got two atoms. That's the last question. But before that, we can see it has two kinds of atoms. So we know it's a compound that happens to be a molecule. And the same exact thing can be said about the blue-red molecules. It's a compound that is a molecule. So it's a compound and a compound, two different substances, and it's a molecule and a molecule. Here's another one. Look at this carefully before you answer. And if you noticed here, there are actually two different kinds of substances here. There are large blue balls with two yellow balls attached, and there are large blue balls with three yellow balls attached. So we have two different substances here. In fact, there are certain compounds that can do this. They can mix together in different ratios. And this has actually been known since the late 1700s. A very famous, brilliant chemist by the name of Antoine Lavoisier actually noticed that they were always in whole number ratios as far as the atoms go within a single molecule or molecular substance. This is before they knew it was molecules itself, but they knew the ratios were consistent. So you'll see that there's the blue with two yellow, the blue with three yellow, so we know it's a mixture. By the standards of mixing in PowerPoint, this is as best mix as I can get, so it's homogeneous. And now let's look at each of them. Well, we can see that they are both compounds because they're made of two kinds of things, and they are both molecules because they have at least two total atoms in them. And here's the last example. Now I think you can see clearly it's a mixture, and now you can see finally that this is not a very well mixed mixture. You can imagine this is, say, one substance on the left and one substance on the right predominantly, so it's obviously not well mixed. So it's a heterogeneous mixture. If we look at the yellow substance first, that is composed of two of the same yellow balls, therefore it's an element, whereas the red-green is composed of two different kinds of balls, therefore it's a compound. So we have an element and a compound. Now if we go back to the yellow again, and we ask the question, is it an atom or a molecule? Well, clearly there are two atoms, so it must be a molecule. And the red-green is also clearly a molecule. There are two kinds of two kinds of atoms in it. So this is a heterogeneous mixture. It is a mix of an elemental form of the yellow and a compound of the red-green. And the yellow is a molecule, and the red-green is a molecule. So here's your little quiz, but now we're talking about actual formulas of chemical substances. And you're going to determine from each one whether it is a compound or element, or if it's a mixture, tell me which things it is. And then you're going to look at each substance and say, is that an atom or a molecule? Well, the first one is water, H2O. So we know it has a single substance of 2 hydrogens and 1 oxygen in a single molecule. So I've already answered the second part. And it's a compound of both hydrogen and oxygen. So we know that it's a compound, and all compounds must be molecules. Chlorine gas, Cl2, this is a very deadly gas. It actually is an unusual color. It's a yellow-green color. In fact, that's where the name chlorine comes from. It's from the ancient Greek word chloros, which means yellow-green. So this gas could kill you very quickly. It's a horrible death. You do not want to breathe this kind of gas. It forms hydrochloric acid in your lungs and will not be pleasant. So chlorine gas has a single formula of Cl2. It's made of only chlorine atoms, so it's an element. And it is made of 2 atoms, so it must be a molecule. Ethanol, we've talked about this formula before, 2 carbons, 6 hydrogens, and 1 oxygen. So we know it has to be a compound. It has 3 different kinds of atoms in it. And all compounds are by definition molecules because they have to have at least 2 atoms in them. Now we have a mixture of nitrogen gas, N2, and helium gas, He. So obviously this is a mixture, so we have to look at each thing. So nitrogen is composed only of nitrogen atoms. Helium is only composed of a single helium atom. So that's an element and another element. Nitrogen has 2 atoms, so it's a molecule. Helium has 1 atom, so it's an atom. Glucose, this is a single formula. It's a formula that has 6 carbons, 12 hydrogens, 6 oxygens. It's one substance, and it is a compound of carbon, hydrogen, and oxygen. And because it has at least 2 atoms, in fact, it has 24 atoms, it's a molecule. Oxygen gas, O2, plus ozone, which is actually O3. You may not have known that. Ozone is a different elemental form of oxygen. So these are both elements because they're both composed of only one kind of atom. And coincidentally, they're both composed of the same atom, oxygen atoms. So they're both elements. The common elemental form of oxygen is O2, though. Ozone is something we don't typically find in the lower atmosphere. We find it in our upper atmosphere to protect us from UV light. So it's actually terrible to breathe at low atmosphere. It's a result of smog, but in upper atmosphere, it's absolutely essential to keeping all life on Earth protected from ultraviolet rays. Now, both of these are composed of at least 2 atoms, oxygen gas with 2 and ozone with 3, so they're both molecules. Argon gas is a gas. It's one of the noble gases, over far right on your periodic table. It's composed of single atoms. They're very happy being all by themselves, and therefore it is an elemental form that happens to be an atom. Iron bar with rust. We've talked about this before. It is clearly a mixture, and it is clearly a heterogeneous mixture, but we have to look at each component. Iron, Fe, and rust, Fe2O3. So let's look at Fe first. This is obviously a single atom element, so it's an element. Rust has 2 kinds of elements, so therefore it's a compound. So we have an element and a compound. And iron is composed of a single atom, and rust is a molecule. So we have an atom and a molecule. Mercury, the only liquid metal, there are actually 2 liquids in the periodic table, elements that are liquids at room temperature, mercury and bromine, liquid that I mentioned earlier. Mercury is a metal. It's a single atom metal. Hg is the symbol. And so it's an element. It's one thing, one kind of thing, and it's only one atom. Gold-plated bracelet. Remember, this is a heterogeneous mixture because the gold is on the outside, the aluminum is on the inside of your bracelet, and therefore these are a mixture of 2 substances, and gold, Au, and aluminum, Al. These are both elements. So it's an element and an element. You can find it right on the periodic table. They're elements. Each of these is composed of single atoms, so it's atom plus atom. It's actually more complicated than that, but for the purposes of Chem 100 and Chem 110, we're going to call them atoms. Cholesterol is composed of dozens of atoms, 27 carbons, 46 hydrogens, and 1 oxygen, but all in one substance, in one formula. Therefore, it is a compound composed of 3 kinds of atoms, carbon, hydrogen, oxygen, and it is a molecule composed of dozens of atoms. And this will end us for this unit, and we'll stop.